Hello student. In my last class we have derived or had given you few formulas of integration. Today we will start exercise 7.1 and this chapter we will see few questions we will do by doing the method of inspection and the rest we will do by using the standard formulas. Okay, that means how to use the standard formulas that we will first try to clear here in this exercise. So first question is find an antiderivative or the integral of the following functions by the method of inspection. So by the method of inspection means, you see, you have to first know what derivative of what function gives you the answer, that required question, this one. Okay, that first you have to know. That means derivative of some function gives you here sine twice x, that you have to know what function derivative gives you sine twice x. So as you know, ddx of cos x, sin x is cos x and ddx of cos x is sin x. So we need sin x, that means we have to take the derivative of cos x. But derivative of cos x leads you minus sin x. So to get sin twice x, we have to take the derivative of cos twice x. But as cos twice x derivative gives you minus 2 sin twice x, because mx formula we can apply. So to remove this minus sign and 2, we have to multiply our function cos twice x by minus half. So we will take the derivative of minus half of cos twice x plus c. Okay, and then by taking derivative, we can apply here ddx of the first function plus ddx of the second function. And ddx of the first function gives you minus half constant, come out ddx of cos twice x, and ddx of constant is 0. Then minus half constant, and what is the derivative of cos twice x? 2 times minus of sin twice x. So minus minus will gives you plus, 2 will be cancelled out, so only sin twice x will be left. So you see, you have to select the derivative of the function in such a way that answer will give. We get the answer. তোমালোকে তাৰমানে এই ফাংশনটো সিলেক্ট কৰোতে এনেকে কৰিব লাগিব যাতে তুমি এই ফাংশনটো পাই যোৱা। যেটো মই জানো যে cos twice x ৰ ডেৰিভেটিভটো হয় sin twice x minus sin twice x. So minus sign to remove কৰিবৰ কাৰণে আমি এটা minus sign ললো, আৰু 2 minus 2 sin twice x হয়, so 2 to remove কৰিবৰ কাৰণে আমি half to লৈ লৈছো, so that we get this sin twice x. Okay, now we are going to apply the integration formula. So definition, so that gives you what? Minus half of cos twice x plus c. I bring this x to the right side, and in the place we will have what? Integration symbol. So this is the solution of integration of sin twice x is minus half cos twice x plus c. So same way, here you go to the second question. You see, in the second question we need the integration of cos twice x, cos thrice x. So cos twice x can be obtained when I take the derivative of sin thrice x. Okay, but there we will have a 3, because cos mx formula m sin of mx, so cos thrice x is 3 sin of thrice x. So 3 will come an extra expression. So to remove that 3, I have to consider 1 by 3 sin thrice x plus c. So 1 by 3 is constant, and ddx of sin thrice x is 3 cos of thrice x. 3 will be cancelled out, only cos thrice x will be left. So by definition of integration, what will have? 1 by 3 sin thrice x plus c is integration of cos thrice x into dx. Hope you understand the method. Next I go to the question number 3. That is what? E to the power twice x integration, this value we have to get. So to get integration of, exponential function integration remains as it is. So e to the power twice x will give you, ddx of e to the power twice x will give you 2 e to the power twice x, that extra 2 will come. So when I take the derivative of e to the power 2x, just to remove that 2, extra 2, I have to multiply it by half. That means I'll take the derivative of half e to the power 2x, so that I obtain the answer as e to the power twice x plus c is just an indefinite integral. So plus will always come, and we know the derivative of constant is 0, right? So plus c will not affect your answer. So minus half will come out, ddx of e to the power twice x plus ddx of c is constant, 0. And whose derivative will be, half will remains as it is, 2 will come out, and ddx of e to the power twice x, so e to the power twice x will be there. That is equal to what? If I take this expression on the left side, dx will come to the right side, and instead of d, when I remove this d, integration symbol will come. So this is the value of integration of e to the power twice x dx equal to half of e to the power twice x plus c. Okay, now I go to question number 4. Your question number 4 is ax plus b whole square. And the derivative of if I take the derivative of a cube expression, then that will give you square expression, is not it? Because the power of an algebraic expression, when the power is a constant, then power will be decreased by 1. So here also ax plus b whole cube, when I take its derivative, will have the ax plus b whole square expression. But there is an extra 3 will come, because 3 into something will give, and also as the coefficient of a is there, as the coefficient of x is a here, that also come when I take the derivative. So when I consider our function, I'll take a constant 1 by 3 extra to just to cancel our expression. So what I have taken here, ddx of ax plus b whole cube by 3a plus c. Then when I take its derivative, 1 by 3 constant, it will come out ddx of ax plus b whole cube will be there, and ddx of constant is 0. So 1 by 3, say here taking the derivative will have 3 ax plus b whole square. But as I think it as x and done the derivative, that is same rule I have applied. So ax plus b derivative is a into ddx of x is 1 plus 0. So only a is sufficient to write. So a and this 3 will be cancelled with this twice a. And by definition of integral, what we have got? Ax plus b whole cube is equal by 3a is plus c is equal to integration of ax plus b whole square plus into dx. Hope you understand this type of things. And sometime what happened, here you will see this thing, just a minute. Sometimes what happened, the questions are given as a difference or the sum of more than 1 or 2 functions. In that case, what we'll do, we will do the functions separately, the calculation of the functions separately, and lastly we add or subtract whatever necessary in the question. So here we need to get sine of twice x minus 4 e to the power twice x. So sine twice x, as I have done earlier, the derivative of minus cos twice x by 2 will give you sine twice x. Minus have come out, minus 2, this one sine twice x will come. So here we see minus cos of twice x by 2 is integration of sine twice x into dx. To get this expression, I need 4. And 1, 2 will come here when I take the derivative of e to the power twice x. So I have considered here 2 e to the power twice x, because these questions are done by inspection. So this 2 will constant come out, and taking the derivative of e to the power twice x, what will have? 2 into e to the power twice x, and 2 to 4. So 4 e to the power twice x will come. So when I take it, the function, this one is equal to what? 2 e to the power twice x, bring this to the right side, give you integration of 4 e to the power twice x. Now to get our answer, you see, we need this sine twice x minus 4 e to the power twice x. Okay, so what I have done, here I have subtracted this one from this expression. So integration of sine twice x dx minus 4 e to the power twice x into dx, this one, so it will be equal to minus cos of twice x by 2 minus this expression. So I have written it like this, and then I can combine this by property of integration, I can combine it into dx. I forget to write down, so please write down this dx here. Okay, and this result we obtain. Hope you understand the method. So now the next questions are direct application of formulas. Okay, so your first question is, find the following integrals. So your question number 6 is integration 4 e to the power twice x plus 1 into dx. Here you see I can first separate, use the sum rule and separate. As in the case of derivative, we can separate it by using what? Integration of 4 e to the power twice x dx plus integration of 1 dx. 1 I can omit also. But don't forget to write down this dx. Whenever this integral sign will come, then immediately dx will also come. And when you use the formula, that integral symbol and dx will be removed. As in the case of derivative, when I take the derivative or apply the formula, the dx symbol will be removed. Just like that here also, when I use formula, then integration symbol and at the same time dx will be removed. So here you see 4 is constant come out. So what is left? Integration of e to the power twice x into dx will be left. And integration of e to the power twice x means what? E to the power twice x divided by 3 and plus here integration of dx equal to x plus c. These are the direct application of the formula. Try to remember the formula. Hope you remember those things. Then only you will get it easy. Otherwise this is very difficult. Okay. So then I go to the next question, number 7. Here you see, as in the case of differentiation, we have the chain rule. That is, we can think x as another function as x, and then we can apply the formula. But here there is no rule like that. If it is a standard formula, then only we can use the standard formulas. Standard form, then only you can use the standard formulas. Otherwise, by using substitution, later on we'll get it next chapter. By using substitution, we convert into standard form and then we apply the formula. So first you try to convert into standard formula, right? And after that, by doing any algebraic expression or whatever you want, substitution, and then only we can apply the standard results. Okay, so integration of the next question, integration of x square into 1 minus 1 by x square into dx. Here we don't have product rule till now. We have not found our product rule, not discuss our product rule. So what I'll do the product of this function. That means I multiply x square with 1 and minus x square with 1 by x square. That give you x square into 1 is x square. X square into 1 by x square will give you minus 1. Then I separate the integral into two parts by difference rule. Integration of x square into dx minus integration of 1 into dx. And 1 into dx, as I told you earlier, that can be written as integration of dx also. Okay, now what is the value of integration of x square? The power x to the power n formula I have to use. Power constant, so power will be increased by 1, that is n plus 1, that is 2 plus 1 is 3. I have written it directly by 2 plus 1, that is by 3. And integration of dx equal to what? X plus c is always put. Don't forget to put this c. Okay, now I go to question number 8. Question number 8 is also an algebraic expression ax square plus bx plus c into dx. And here you see no need to do any product or division because these are all in the standard form. So I have separated into as a sum by using sum rule. So it will be integration of ax square into dx plus integration of bx into dx plus integration of c into dx. Right? Then constant, by that constant we can take out of the integral, as in the case of differentiation. A will come out and integration of x square into dx will be there. And b is there and integration of x into dx. And c constant come out, integration of dx will be there. So here I can apply x to the power constant. Except x to the power minus 1. I can use everywhere x to the power n formula. So I can use here x to the power n formula gives you what? X to the power 2 plus 1, that is 3, by divided by 2 plus 1 is 3. Again, like here, b is constant come out, and here no power is given means the power is 1. Okay, so 1 power, when I use x to the power 1, that is 1 plus 1, that will be give you 2 by 1 plus 1, 2. C, constant come out, integration of dx x to the power 0 formula, or by formula we know it x, and plus c1 is another constant. Always you have to give a constant, as there is c, so I have used here the constant as c1, or another constant k, or whatever you want you can apply, but don't forget to put this constant. And again, extra line I have written like this, separating the constant and the variables. Now the next question is integration of 2x square plus e to the power x into dx. Again, you see, you know the derived integration of x square and also e to the power twice x. That means these are in the standard form. So I can separate into sum of two integrals as integrals of sum. After that, what I have done, integration of 2x square dx plus integration of e to the power x dx. Then 2 will come, constant come out, x square dx will be there, into the power, just have keep it as it is. Then 2 is there, x square integral power increase, remember that. X 2 plus 1, 3 by 3, and to the power x integral is e to the power x by plus c. And this also I have written one extra step. Now I go to question number 10. In your question number 10, you see root over x plus 1 by root over x whole square is there. But there is no square formula we have got. But you know, a minus, in integration we have no formula of square of any other function. Power we cannot use. You cannot use here x to the power n formula. Because standard, when it is in the standard form, x to the power something, then only we can use that formula. But here we can use a minus b whole square formula, which will be a square minus twice ab plus b square. Our a is root x, so root x whole square minus twice ab. So twice root x into b means 1 by root x. Plus b square, it is 1 by root x whole square. Then after that, when I square this root over x term, x will be there. Root x cancel, only 2 will be there, and it is 1 by x into dx. Now, all these are in standard form. Constant, there will be no problem with constant. So I have separated into 3 parts by using sum and difference rule. X into dx minus 2 into dx plus 1 by x into dx. Okay? X derivative integration is x square by 2. 2 is constant, come out. Integration of dx is x. Integration of dx by x. That means 1 by x dx equal to what? Log of modulus of x. I can put here a modulus sign if you want. Plus c. Better to put this modulus sign. Okay? Now question number 11. Here you see x cube plus 5x square minus 4 divided by x square. There is no division rule in integration. But by algebraic division we can divide it. Single expression is there. So polynomial by polynomial we can divide by monomial term-wise. X cube by x square, 5x square by x square minus 4 by x square term-wise we can divide. And after division we have done the simplification. That is x cube by x square is x square cancel out, plus 5 will be there, minus 4, and this as we don't have result for except x to the 1 by x. There is no result for integration. Algebraic power, constant power. So I have bring this to the numerator and can be written as x to the power minus 2. I hope you remember it now. When I bring this positive to the numerator, it become negative. So now separate term wise, x dx minus plus 5 dx minus 4 x to the power minus 2 dx. Then I have just separated I just bring the constant outside, and here I can use the formula, use wherever possible, otherwise use, here I have used the formula of x, that is power 1 x square by 2. 5 constant come out, integration dx I have just written here one more step, 4 constant, and this was just left as this. Then x square by 2 plus 5, integration of dx is x, 4 is constant, x to the power minus 2 is equal to what? Minus 2 plus 1 by minus 2 plus 1. Minus 2 plus 1 will give you minus 1, so x to the power minus 1 by minus 1 plus c. Then I adjust the negative sign, x square by 2 plus 5x minus minus plus 4, x to the power minus 1 can be written as 1 by x plus c is the answer. Same procedure we have applied in question number 12 also. Polynomial by monomial, term-wise I have divide, right? Then division will give you x cubed by root x into dx, 3x by root x into dx, 4 by root x into dx, okay? After that, what I have done, root x by cube by root x. Root x means power is half. So a to the power m by a to the power n formula is a to the power m by n. So it can be written as x to the power 3 minus half into dx. Then next is x by root x. So x to the power 1 minus half into dx. 4 constant come out. 1 by root x is there. So x to the power minus half. Power half in the denominator, put it in the numerator, become negative. Okay. Then here I have done the simplification. Taking LCM, it is 2 is the LCM. 2 to the 6 minus 1, 5. So I have done it directly. That is 5 by 2 into dx. 3 constant come out. And here also I have done the simplification by taking LCM. 2 is the LCM. 2 minus 1 is 1. So it is half is left. And this, there is nothing to do. Only 4 I have just written outside. All it is there. So here I have used the formula because these are in the standard form. X to the power n formula can be used. N is 5 by 2. So 5 by 2 plus 1 by 5 by 2 plus 1. X to the power 3 is constant here. X to the power half can be written as half plus 1 by x to the power half plus 1 by half plus 1. 4 is there. X to the power minus half plus 1 by minus half plus 1 plus c is always there. When you use the formula step, immediately don't forget to put the constant of integration c. This is very important to give indefinite integral. Otherwise in exam, the marks will be deducted. So I have done the simplification part here. You see this one is 5 by 2 plus 1 is x to the power 7 by 2 by 7 by 2. 3 is there. X to the power, this is 3 by 2 by 3 by 2 plus 4, and here it is half by half plus c. This one I have written as a reciprocal, 2 by 7, x to the power 7 by 2. When I take it as a reciprocal, it becomes 3 into 2 by 3, x to the power 3 by 2. 4 into, this is 2 by 1, x to the power half plus c. Again, when I do this simplification part, that is equal to what? 2 by 7, x to the power 7 by 2. This cancel out 2, x to the power 3 by 2. 4 to the 8, x to the power half into this one. Hope you understand up to this. Next, I go to the next question. That is what? It's a division polynomial by polynomial. So I cannot divide it term-wise. I have to use long division. Long division I have shown here. X minus 1, when I divide it, first you have to divide this expression by x. X square will be there. So x square will be the first term of the divisor. I mean quotient. So x square into x will give you x cube minus x square. Subtract, these are cancel out. All the terms come down. X by x give you plus 1. So plus 1 is there. When I multiply, we get it. So we have got our quotient is x square plus 1. This is very simple. Separate it into two parts and do the integration. Power increase by 1 by 3. Integration of dx is x plus c. So always you see everywhere I have applied formula. So try to remember the formula properly. Now the next question, x minus 1 minus x into root x into dx. I can use product of this one expression. There is no product rule till now we have discussed. So root x into x, 1 is root x root x. Root x means to the power half, x root x means x to the power 1 plus half. That is x to the power half into dx, and 1 plus half is 3 by 2 into dx. Applying the formula, half plus 1, that is 3 by 2 by 3 by 2. 3 by 2 plus 1, 5 by 2 by 5 by 2 plus c, taking reciprocal 2 by 3. And this is also result we have got. Now the next question is also similar with the last one. The product with this expression I have done first, 3 half plus 2, okay. Then this is 2 is constant, x to the power 1 plus half, 3 into x to the power half is dx. Simplifying step I have done, 3, 2 LCM, 2 to the 4 plus 1, 5, 2 LCM. Here also 2 LCM, 2 plus 1 is 3, and this one. Now I can separate it. Constant I am taking outside at the same step, 3 and x to the power 5 by 2 plus 2 is constant outside. Integration of x to the power 3 by 2 into dx. 3 constant come out. X to the power half into dx is there. Okay. So after that, do the integration step. That means apply formula. Integration symbol will be removed. 3. This is 5 by 2 plus 1, that is 7 by 2 by 7 by 2. Here I skip some steps. If you want, you can write down those steps. 2. This is 3 by 2 plus 1, that is 5 by 2 plus 5 by 5 by 2. 3 is there, and x to the power half plus 1 is 3 by 2 by 3 by 2. Taking reciprocal and simplifying, we got this step. Now the next question, number 16. Here all are in standard form. First we'll see whether they are in standard form or not. If yes, then I separate it by using sum or difference rule. So I have separated the integrals like this: twice x dx minus thrice cos x dx plus e to the power x dx. Constant come out, integration of x is x square by 2. 3 come out, integration of cos x is sin x plus e to the power x integral is e to the power x and plus c. Since all the integration are done, so plus c don't forget to give. Same way the next is also all are in the standard form, so separated, right? After that we apply the formula. Sin x integration is minus cos twice x, and half can be written as 3 by half plus 1 by half plus 1, and do the simplification step. Okay, so few more questions are left. Today I want to do actually whole chapter, the same video, so I have done here the few more questions. Here the next question, number 18, is sec x into sec x plus 10x. Obviously I have to do product. Sec x into sec x give you sec x whole square, which can be written as sec square x into sec x into 10x. You see both of them are standard form, so I can separate it into two parts: integration of sec x dx, integration of sec x 10x dx. What is the integration of sec x? Is 10x, because you know the dx of sec x 10x is sec square x, so integration of sec square x is 10x and sec x 10x is sec x plus c, right? So the next question, here some simplification we have to do. If I directly think it that cos x square, if division is not there, so cos x, if I bring to the right, I mean in the numerator, sine will be there, but the sec and sine we cannot do it together. So if you don't know any that directly you cannot convert into standard form, then convert into sine by cos form. Sec we know 1 by cos square, and cosec we know 1 by sine square. So taking the reciprocal, it will become in the numerator, that is sine square and by cos square. Sine square by cos square give you 10 square. And you know 10 square is not standard, but you have to remember this step. 1 plus 10 square we know it's sec square. So sec square, 10 square can be written as sec square minus 1. This step you have to remember. Frequently used formula. Whenever we have 10 square form, always you convert into sec square minus 1. Try to remember this step. So integration of sec square minus integration of dx. Sec square integration of 10x, integration of dx is x. And hence the completed plus c. Now question number 20. This is 2 minus 3 sin x by cos square x into dx division, and single expression to term wise divided. 2 by cos square dx, 3 sin x by cos square into dx. Easily we can write down this one. 2 come out in 1 by cos square is sec square. Formula, if you remember, these are very simple question. 3 constant come out, but here you have to know one. You have to remember this step. When we have sin by cos square or cos by sin square, you separate it into two parts. Sin by cos, because sin by cos square, if I write down in the form of sec square, no standard form will come. But if I write down the sin by cos into 1 by cos, then tan and cos sec will come. And second tan give you tan and sec, same thing. So it is derivative of integration of sec x. So result we have got. Now the next question, find the antiderivative of this expression. Equal to what? It's a multiple choice question in the book. So I have written in like this. Antiderivative means what? Integral. We have to get the integral of this expression. So put as a power, it is x to the power half and it is x to the power minus half dx. Taking integration, x to the power n formula, half plus 1 by half plus 1, x to the power half minus half plus 1 by minus half plus 1 plus c. Doing simplification, we have got this step. One more question in this exercise left. Let us complete that one. Question number 22. You know question number 22, we have ddx of fx is equal to 4x cube minus 3 by x to the power 4 is given, such that f of 2 is equal to 0. We have, our aim is to get the value of fx. You see here it is in the form directly formula. I have to use here direct integration formula, because the dx is there, and we know to get fx I have to do integration. So what I have done, I have written the given expression, this one, and then try to get the value of fx. When I want to get fx, you have to bring dx to the right side, and d will give you integration symbol. Take integration. 4 x cube power is 3, so power will be increased by 1, x to the power 4 by 4. 3 is constant come out, and this power is x to the power minus 4 plus 1 by minus 4 plus 1. And doing simplification, we have got it. But you see, as here f of 2 value is given as 2, 0. So I have to find out f of 2 now. Actually, this value will give you the constant value result. F of 2, I have substituted 2 here in fx. This is your fx. 2 to the power 4, 2 to the power minus 3 plus c. F of 2 value is given as 0. This is 16 plus 1 by 8 plus c. Taking LCM and doing calculation, 1 to the 28 plus 1, and this is c is equal to, well, we have got it what, minus 129 by 8. Then I have just substituted the value of c in our fx. This is your fx. Fx is x4 minus plus x to the power minus 3 plus c. So I have substituted x to the power 4 plus x to the power minus 3 can be written as 1 by x cube, and substituting the value of c, this one, we have got our answer. And here this exercise 7.1 is completed. See the video properly and write down the solutions. Thank you.